Hello and welcome back to my LeetCode journal. Today I'm going to be attempting the second question off of the John Prashad list of LeetCode patterns. The question is named missing number and falls under the pattern of arrays and bit manipulation. And its difficulty is easy. I've personally never messed around with bit manipulation much. I just very briefly touched on it in the course the semester that I did, but other than that, I'm not familiar with it, so I really doubt my solution is going to be optimal. But yeah, I'll obviously make sure to go into the discussion to see a better solution to the question. But I have the question open here, question 268. And the question states, given an array nums containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. And there's three examples given. The first one is a list of 3, 0, and 1. And in this 2 is missing because 0, 1, and 3, but like if it was sorted, there's no 2 in there. And then we have a list of 0 and 1. But the output in this case again is 2. Since we have two numbers all in the range of 0 to 2, but 2 is the missing number because it doesn't appear in the list. And in this one, it's just a much bigger list, but essentially we have all the numbers up to 9, and the only one missing is 8, so we return that. Obviously, one thing we could do is to sort it. Python has a dot sort, but even just sorting results in an n log n big O time, I believe. Like the fastest sort we could have would still be n log n. And I mean, that could work, but it might not be the most optimal way to do this. So another way we can do this is we can put everything into a dictionary and then check whatever is not present in the dictionary. Because dictionary lookup time is just O of 1, but that might not be too fast either because first we have to go through everything and put it in a dictionary, and then we have to go through the dictionary to check what is missing. So that doesn't seem too good either. Let me just do that for now, and then we'll see if we can make this better as we go along. Num in nums. Yeah, we could just have a dictionary outside here called numfig, and then we could just put everything in there. Numfig num equals to 3. I don't know. You could do anything. Honestly, put 1 in there, put 0 in there. Anything works, just as long as it's in there. And then what we could do now is for I in range 0 to n plus 1, if I mapping nums6 is true, or what do we have to do? Oh, return the only number that's with it. So essentially what I'm just trying to do here is parse through the entire list, put it into this dictionary, and then parse through all the numbers from 0 to n, inclusive of n, which is why I think I might need +1. I might need to change that if that's not how the range works. Essentially, if this number isn't in the dictionary, and I think dictionary lookup is of 1 time, then we can just return that value because it wasn't in the initial list that was given to us. This should take n time, and then this takes another n time, worst case. And so this should just be O of n, which is one of the follow-ups that I had. Maybe I should have shown this before. I did read up just a tiny bit before the the video, but essentially they're asking for O of one space, which this definitely isn't, and O of n runtime complexity, which I think this might satisfy. But let's just first test the code to see if it even runs. Okay, well, this hasn't worked. Oh, okay, because we don't have n. We just probably need len of nodes. My bad, I thought we might have been given n because I was reading it from here. We just have nums, which is the initial input list. Might need to do len nums plus one, but let's just see. This might work. Okay, so this does seem to work. Because in the case of this one, it would just put 3 into the dictionary first, 0 and then 1, and then we'd go over the loop, the next loop, and it would check 0 initially. Oh, 0 is in there. So because it's if check would never pass. And then 1 would be in there because we parsed through 1 initially, but then go to 2, and this if check would become true because 2 isn't in there, and it would just return true. This does satisfy the time complexity, I believe, but obviously it does not satisfy the follow-up space complexity. So, I mean, I'm gonna just, I'll cut through, I guess, but I'll spend a bit of time thinking if I can come up with a better solution, but otherwise I'll jump right into the discuss section. Okay, so I was just going through the test cases, trying to see if I could come up with a better thing that might take of one space for this follow-up. And one of the things I guess we could also do is just take the sum of the list that's provided, and also take the sum of the range that actually should be from the number of elements. So, for example, in this case, we would just take the sum of 3, 0, 1, which would give 4. But then, because we have 3 numbers, the range is 0 to 3, and so we'd also take the sum of that range. So it'd be 0 plus 1 plus 2 plus 3. Which would give us 6, and then we just minus the difference between the two values, which would give us the missing number. And I think the assumption is that something is always missing. So, I don't think we'll have the case that 0 is missing. So that might actually work. Let me just see if I can code that up. Let's just comment that out. And so if I begin writing that out, I don't know how the spacing works actually. I mean, I don't think it matters, but essentially, first let's just say some nums. We can just store that as the sum of the list that's provided to us. We can just use the Python sum function over the list that's given as an input. And so now some nums would be the sum of the input list, and now we need the sum of the actual range that this is supposed to represent. And so we can just store len as a variable for now and just take the len of the input list. So this would give us the the range essentially. So in the case of the first one, we have 3 elements, so this would give us the range. We need to go from 0 to 3. We can use this variable. I don't know how if I could pass the range function into sum. So I'm just going to use a for loop for simplicity, but I'm sure you could probably do that. Something like sum and then range, and then I'm actually going to try it. But let's be fancy. Then we could just pass this sum length and store this. This might not work, but whatever. And we could just store this in a variable called sum range, and we could just return the difference between the sum range and some nums. Let's see if this works at all. Okay, fantastic. Oh, it's called nums. That's why it didn't work. I mean, this could still be an error, but okay. Well, in this case, we got -1. That's interesting. How did we get -1? So essentially, the range came out to be smaller than the sum of nums. Do I by any chance need a +1 on that? Okay, so that's interesting. This might not have been working. It might have just been ignoring the last case. Okay, but I mean, okay, let me just, for future insight, let me just range, let me just find out if range works the way I think. So the range is exclusive of the last one. And so in this case, we have length to be 3, but we do need to include uh, 3 as a sum that get as a number that gets added into the sum that we have. So we essentially need this to go to 4 instead of 3, so we exclude the 4, but make sure we include the 3. So I think it might have needed it there as well. That somehow just worked, maybe because we were ignoring the edge case. But yeah, this should still be within O of n time, because even I don't know how sums exactly into it, but I'm sure it's O of n time. Even if we just had a for loop iterating through everything, len is just constant time. This summation would work exactly the same as this one, and then the subtraction is obviously constant time. And the only thing we're storing are these few variables. So I think like we're not. This isn't dependent at all, I think, on the size of the thing provided. So this should be of one space, I think. So I'm going to go with this for my submission and go into the discuss section to see how other people tried this problem. Okay, so I found this discussion post where the guy claims to have the exact runtime and space complexity as the question asks for, which is O of n running time and then O of one space complexity. Essentially, he starts with two arrays. He says that nums is the array with index of 0 to n minus 1. And then he calls this variable res, which is the virtual array with the index of 0 to n. And obviously, he just says res should contain the missing item from nums, which was what the question asked of us. He assigns res to initially start off as the length of the list. So in the example that we had, like the first example we had of 0, 3, and 1, res would start off at 3, and then he just iterates through the input list, and then I essentially gets assigned to every item in this virtual array of indexes up to n minus 1. So this will essentially loop from 0 to n minus 1, and then each time res gets appended in the sense that it's the value of I is added to it, and then he subtracts the value at the ith position from the list, and then that value is returned. If that doesn't make too much sense, I've just made a little notepad here of exactly the steps that have been taken here. This is the input list, and this is the sort of virtual list that this person is traversing through by taking the range of up until the length of the input list. And we're starting at 3 because the input list has a length of 3. And when I is equal to 0, so at the first iteration of the loop, we take the initial value of res, which is 3, add I into it, which starts off at 0, and then we minus nums at I. Since the nums at 0 or the 0th position of the input array is 0, and so we just get 3 plus 0 minus 0, which is still 3. At the second iteration, when I is equal to 0, we still have res is equal to 3 from the last iteration. We add I, which is 1 now, and then we minus nums I, which in this case is 3, which gives us 1. And then the final iteration we have in this case is I equals 2. So we had res coming in as 1 from before. We add 2 to it, and then we minus that position, the element at that position in the input list, which is 1. And so we get 2, which is a missing number. And that's how this person's done it. To be honest, I don't think I would have come up with this solution if this question was asked of me. Still not too sure how they came up with this maths. this just seems to make a lot more sense to me. If I'm wrong on the space complexity and all that, that might be the case, but I think I'm happy enough with this solution. But yeah, that does it for this video, and I'll see you guys in the next.